Welcome back, everyone. Today, we are moving to the second pillar of system design, scalability. Imagine you build a beautiful app. Today, you have 10 users. And it works perfectly. But what happens tomorrow when a famous YouTuber shares your app? And suddenly you have 1 million users. Will your app survive? Scalability is how we answer that question. Scalability is not a simple yes or no label. We never say an app is just scalable. Instead, it is a continuous question we ask ourselves: if our traffic doubles tomorrow, how exactly will we add more computers or memory to handle that pressure? To fix a slow system, we first have to measure the pressure. In engineering, we call these numbers load parameters. For example, a web server might measure how many requests it gets every second. A database might measure how often people read data compared to how often they write new data. You must know your numbers before you can scale. To make this very easy to understand, let us look at a famous real-world example. We are going to look at Twitter's architecture from the year 2012. On Twitter, users mostly do two things. First, they write a new tweet. In 2012, Twitter received about 4,600 new tweets every single second. Second, users open the app to read their home timeline. This happens much more often. Twitter handled about 300,000 read requests every single second. Now, saving 4,000 tweets a second is actually very easy for a simple database. The real problem for Twitter was something called fan-out. Think about a celebrity. When they write one single tweet, that one tweet must be shown to millions of followers. One small action spreads out like a giant tree. This fan-out creates massive pressure on the servers. So, how do we build this? Let us look at the first approach Twitter tried. In the beginning, when a user wrote a tweet, the server just threw it into one giant global database. This made writing very fast. But reading was very hard. When you opened your app, the database had to search through millions of tweets. Find the people you follow. Gather their tweets. Sort them by time. And finally show them to you. This approach failed as Twitter became popular. Why? Because people read their timelines 300,000 times a second. Asking a database to do heavy searching and sorting 300,000 times a second is impossible. The servers could not keep up. And the app crashed. Because reading was too slow. Twitter changed their entire design to approach number 2. They decided to do the hard work at right time. They created a digital mailbox for every single user, using fast memory called a cache. Now, when your friend writes a tweet, the server instantly makes a copy of it and drops it directly into your mailbox. When you open the app, the server does not search at all. It just opens your mailbox and shows you the tweets. Reading is now instantly fast. This mailbox idea worked perfectly for normal people. But it created a huge new problem: celebrities. Imagine a famous singer with 30 million followers. When they post one single tweet, the server must make 30 million copies and push them into 30 million mailboxes. Twitter tried to do this in under 5 seconds, which took a massive amount of server power and caused huge delays. To fix this final problem, Twitter realized they had to combine both ideas. They created a hybrid solution. Today, they use the best of both worlds. For normal users who only have a few followers, Twitter still uses the mailbox approach. It copies tweets directly to the followers. But for celebrities, they stop using the mailbox. Instead, when you open your app, the system quickly fetches the celebrity's tweet live, on the spot, and mixes it into your timeline. Why is this story so important? It shows us that true scalability requires deep, careful thinking. There is no magic button you can press to make an app scalable. You must study how your users behave, measure the load, and create smart, custom solutions. That brings us to the end of our discussion on scalability. Next time, we will explore the final pillar, maintainability. Thank you for watching, and I will see you in the next video.